numbers important for a computer. So before we start, we have to know what is a computer. So a computer is an electronic device that processes information and data and works on sequence of arithmetics and logical operations. It works on electrical signals. Now you're having a question in your mind, what are electrical signals? So the base of electrical signals is electricity. The movement of electrons power up electricity. There are two major concepts in electricity, voltage and current. When we have to send a message from one module to another module, we have to either fluctuate the voltage or the current. So what is the easiest way to understand how the current or the voltage is passed from one module to another? So the easiest way to understand this is by switching on a lamp and switching off a lamp. So here you can see that this is a lamp which has a Hello Kitty. When I switch on the lamp, it's 1. When I switch off the lamp, it's 0. So now you're having a question in your mind. What is 0 and 1? So 0 and 1 are binary numbers. And this all happens on a tick. Now what are binary numbers? So binary numbers are the only numbers a computer can understand. So 1 or 0 8 times makes a byte, and as much bytes a computer can process is known as its processing power. And in a fraction of second, and a fraction of second can be millisecond, microsecond or a nanosecond, and this is called a clock speed. So now my example is the number 5. So we will divide 5 by 2 because we have to play only with 2 to convert a positive integer into binary number because binary numbers only have 1 and 0, and 1 and 0 are two numbers. So we have to play with 2. So 5 by 2, as you can see, it comes in a fraction number because it is not congruent to 2, and I have converted it into a decimal number which is 2.5. So now I have to round it off to the nearest integer which is 2. So now I am going to do 5 modulus 2. Now you're having a question in your mind, what is modulus? So modulus is the remainder of a given division question. So in this modulus we have 5 modulus 2, which means when I divide 2 by 5, what is the remainder of that question? As you can see here, when I tried to divide 2 by 5, the answer, it was not congruent, which means that it was not divisible by 2, and the answer came in a fraction, and I have converted into 2.5 and then rounded it off to the nearest positive integer which is 2. So when I divide 2 by 5, the answer, the remainder is 1. So now the next number from here which we get is 2, and now we have to divide 2 by 2 which is equals to 1. Because as you can see here that 2 is congruent to 2, which means it is divisible by 2. So now over here I am going to do 2 modulus 2 which is equals to 0 because 2 is congruent to 2 and there is no remainder. Now I have to tell you a trick over here that if we modulus any number by 2, check if this number is an even number, it will be 0. If this number is an odd number, it will be 1. So our next number to divide is 1 because we are getting it from the division question over here. So 1 divided 2 equals to 0.5. Again, it's a fraction question. The answer comes in a fraction, so I have to convert it into a decimal number. And when I converted it into a decimal number, it is 0.5. And now we have to round it off to the nearest positive integer, which is 0. So now I'm going to do 1 modulus 2. And as you can see over here that 1 is not congruent to 2, and the answer comes in fraction, and I have converted into a decimal number and I have rounded it off to a positive integer which is 0. So the answer will be 1 as it is not congruent to 2. And we can also use my trick that when we modulus any number by 2, check if this number is odd. As you can see here, this number is odd, and when a number is odd, the answer is 1. So now you are thinking we have done all the process, what is the answer? So we will take the last modulus. The answer of the last modulus is 1. So we will count from the last modulus answer, which is 1. 101 is the binary number of 5. Thank you and have a nice day. Don't forget to like and subscribe.